Hello, this is Mrs. Mooney, and this is your very first video about sets of numbers. We are going to start by dividing our sets of numbers into two categories, real numbers and imaginary numbers. Every single number that exists in the whole wide world is going to fall in one of these two categories. Real numbers are all of the numbers on the number line, and then we have our imaginary numbers, which do not have any points on the number line. And when you're given a number and you're asked to tell if it's real or imaginary, it's very easy because imaginary numbers are always going to be the square roots of negative numbers. Or actually any even roots, but what you're most used to seeing right now would be square roots. So anytime you see an even root of a negative number, it's going to be imaginary. So if I said, what is the square root of -3? Well, you would know, okay, that's imaginary. Even if I had a real number out in front of it, and then I said 5 square root of -2, that's negative, it's imaginary. So yeah, square root of -3, 5 times the square root of -2, even if I said negative square root of -9. Because that throws people, they think, oh, two negatives make a positive, and they look at negative and negative and they go, oh, well, those cancel out. But they don't, because the square root right here is in between them. So this is saying the negative square root of -9, which is the negative of an imaginary number. And so now, if I asked you for a number to classify real or imaginary, and it was anything other than the square or the even root of a negative number, it would be real, like 3, or -17, or 4. Or even any square roots, that's fine as long as they're not negative. Square root of 5. Or even negative square root of 5 would be okay as long as the negative's on the outside. Some other real numbers. Some weird numbers, 4/3. Or 2.812. It doesn't matter what number it is. Even pi is real. They're all real if they're not the square root or the even root of a negative number. Okay, so now we're going to break it down a little further. Our imaginary numbers, if it's imaginary, you're done. You don't have to further classify it. But if it's real, we've got two categories we're going to take down from this box. So, if you're taking notes, which you should be, and you definitely are now, you write these boxes down, you fill them in, and then below real numbers, you go on and you make two boxes, one for rational numbers and one for irrational numbers. Okay? Rational numbers are numbers that can be expressed exactly as a ratio. See this word ratio? And we all know a ratio is a fraction, so a rational number can be expressed as a ratio of two integers. And we will discuss integers in a few minutes. All right, an irrational number then cannot be expressed exactly as a ratio of two integers. For example, if I tried to take the square root of 2, I would get a number that's a weird decimal, but it goes on forever, and it's some weird thing, and you can't make it into a perfect fraction. Or even a negative square root, or even a negative cube root, say the negative cube root of 11. That one doesn't come out nice and clean, so it cannot be the ratio of two integers. Another one that you can think of would be pi. We've all talked about how pi goes on and on and on and on forever, no pattern and no repeating, and so pi is an irrational number. Whereas our rational numbers then, and I'm going to go back to a smaller pen, our rational numbers would be, the fractions, 4/5, or, oh, look, the dryer's ready, or -2/3, or even 7.3. That would be rational because that is equal to 73/10, isn't it? So that's rational. Negative numbers can be rational. -2, because that, it's not written over 1, but you can express it as -2/1, so that's still rational. If I gave you the square root of 9, because that equals 3, that's rational. And let's talk about the repeating decimals, 0.333 repeating. That's 1/3, so that's a ratio, that's a fraction. Anything that can be expressed as a fraction, even if it's not immediately expressed that way as a fraction, like 7.3 or whatever, if it can be, then it's rational. Okay, now we're going to take each of those two categories and break them down into two more. So rational gets 2 boxes underneath it, and irrational is going to get 2 boxes underneath it. We'll start with the rational numbers. Our rational numbers can be either integers or non-integers. Integers are going to be all of the positive, negative, and 0 whole numbers. These are all the numbers with tick marks on the number line. 1, 2, 3, 4, 5, -1, -2, -3, and 0. 0 is included, so those are our integers. Let's see, we'll give some examples. So 2 is an integer. And -17 is an integer. The year 2014 is still an integer. And 0 is included in those. All right, now our non-integers are going to be all the numbers that are in between the integers, all the fractions and decimals between them. An example of a non-integer would be 3/4, or even mixed fractions, 1 and 2/7. That's between 1 and 2. We can have negative non-integers as well, like -4.63, because that's between -4 and -5. All right, we're also going to take our irrational numbers and break them into two groups, and those are going to be radicals and transcendental numbers. All right, radicals, you know what a radical symbol looks like? It looks like this, and it can be a square root, it could also be a cube root, a fourth root, a fifth root, so we'll put a little n here. Any root. And that could be the square root of 5. That could be the negative cubed root of 11. It could be the 8th root of 16. Anything that is under a radical symbol that doesn't reduce down to a whole number. So in your notes, put nth roots of integers. All right, our transcendental numbers then cannot be expressed as roots of integers. And there are two transcendental numbers that I want you to know. One of those you already know, and that's pi, because pi is 3.14159265358 and so on, forever and ever. There's no end. We can't put it as a square root. We can't put it as a fraction. We can't put it as anything. It just has to be written as the symbol pi. And another transcendental number that we will learn about later this year is e. It's 2.71828, etc., etc. So if you just know pi and e, you're good to go. All right, now out of those 4 boxes, the only one that we're going to break further down is integers. So once you're non-integer, radical, or transcendental, you can stop. It doesn't break down any further. But our integers can be categorized as some of these 4, and these aren't mutually exclusive. That can be in more than one of these boxes. Our integers include the natural or counting numbers, which means if you think about the original people that learned how to count, the cavemen out there, you know, they were very primitive and they could count sticks and rocks. So their counting numbers are 1, 2, 17, 47. All of the positive integers that are greater than 0. So remember, if you can physically count something that exists with it, like rocks, then it's a counting number or a natural number. All right, the next one we have are our digits. And I just want you to picture your phone. The digits are the 10 numbers that we have that all of our other numbers are made up of. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Every number that we have has some form of those symbols written in it. All right, and then we have even and odd. Hopefully you guys know the difference between even and odd. However, it is important to note right now that 0 is neither even nor odd. So our even numbers are divisible by 2. You know, like 2 and 8 and -40. Anything that's divisible by 2 evenly. Our odd numbers then are integers that are not evenly divisible by 2. For example, 1 or 15 or -723. Those are not evenly divisible by 2. And then we have that one special number that is neither, and that would be 0. Okay, so those are all the classifications of numbers that we expect you to know for Algebra 2. We've started off with real and imaginary. Real broke down to rational and irrational. Rational broke down to integers and non-integers, while irrational broke down to radicals and transcendentals. Integers broke down the phone again. My goodness, I'm popular today. Okay, integers broke down into natural or counting numbers and digits, and even and odd numbers. So those are all different ways we can classify integers. All right, now you guys have a good evening, and I'll see you in class tomorrow. Bye.